Everybody else is here. Okay, good. Okay, PowerPoint. Okay, the nervous system. So what does it do? It controls rapid response situations. The endocrine controls the longer duration. Okay. Please turn off microphones, okay, because I can hear like somebody's swimming or something. Okay. So the nervous system takes care of rapid responses. Uh, putting your having a reflex when you touch something hot or uh, a very, very fast event. Endocrine uh, growth hormone, for instance. Okay. So these are two systems that control uh, rapid responses and slower responses. So we have a central nervous system, okay, peripheral nervous system outside the CNS. We receive sensory input through the afferent division, and we have motor uh, output from the efferent division. Is that somebody else checking in? Yep. Okay, good. Okay, so we're all aware of our nervous system, and best to everybody. I'll do everything I can to accommodate everybody's needs. I was happy to take care of a lot of requests during the time during spring break. Okay, so make sure you know what afferent division information coming from the exterior to the central nervous system, efferent division signals leaving the central nervous system, motor output, movement, and so on, glandular activity. Okay, so here's a good summary. Central nervous system where information processing is taking place. And then we have two inputs in the afferent system, receptors such as pain, touch, heat. Uh, that's your external receptors. Then you have internal receptors, how full your stomach is, uh, the state of your bladder, the amount of waste in your uh, lower intestinal system. So that's the afferent nervous system. Motor, com- com- motor commands send information to skeletal muscle. We have a lot of learned activities there, uh, walking, riding a bike, driving a car, and so on. And the autonomic nervous systems takes care of uh, regulation of blood pressure, heartbeat, glandular activity. Glands release salivary glands and controlling adipose tissue. Those are two automatic systems, and that's the motor output. It also helps monitor uh, digestive system, bladder, lung function, and so on. Two classes of nerve cells, neural cells. Read that, please. Okay. There are three classes of neurons: sensory, motor, and association neurons. So this is the afferent system. Okay, we got somebody else joining us. Okay, good. So efferent neurons, and interneurons. They coordinate the interplay between sensory neurons and motor neurons. So what does a nerve look like? Uh, take a moment, read through that, and then let's look at this is a multipolar neuron. It has a nucleus, a cell body, a nucleolus, Uh, it's axon hillock, and it has an axon, and it has synaptic terminals. So nerve impulses always travel away from the cell body, starting at the axon hillock, and this would be a motor neuron or efferent neuron that causes muscle contraction. So three classes of neurons, structural classes. So we have three types here. A multipolar neuron, which is the most numerous. It's a classic view. The cell body, the axon hillock, the axon, and the synaptic terminals. Unipolar neurons are the sensory neurons, and bipolar neurons are found uh, in a few places, such as the eye. Okay, what are the types of neuroglial cells? So we have star bodies, star cells, uh, oligodendrocytes. They're responsible for myelination, which means they wrap white matter or fatty substances around the various nerves, certain nerves, and that helps conduction speed. Microglial cells are defense cells, they're phagocytic, and ependymal cells line the brain, spinal cord, and cavities, and uh, they're a source of cerebral spinal fluid. So if we look at a picture, we'll take a moment to focus on that. So here's an oligodendrocyte. Its job is to uh, wrap myelin around an axon to increase conduction speed. We have a microglial cell, which is phagocytic. It's going to patrol and look for any foreign object or foreign cell that has to be eliminated. Astrocytes are going to be involved in the blood-brain barrier, uh, in controlling what substances move in and out of the brain and within the brain. And then we have the ependymal cells, which line the cavities, like the vesicles within the brain, and where cerebral spinal fluid is produced and circulated. So in the peripheral nervous system, we have cells that uh, form the myelin sheath on myelinated axons. That means that these nerves are surrounded by a fatty substance, myelin, and it allows conduction speeds to be greatly increased. So these are in the PNS. So if we look at a myelinated axon, we have here, you can see the covering, the Schwann cells. Here's the Schwann cell nucleus. Here's the axons. So these are multiple uh, nerves insulated with myelin. The neurolemma is the outside barrier or the outside boundary for the cell. So you can see that the myelinated axon will be surrounded by myelin, whereas unmyelinated, you look here, uh, are not covered with myelin. Okay, so neurons communicate, control functions, information processing. Neuroglial cells outnumber neurons and have helped preserve the physical and biochemical structure of nerve tissue. Very important, not studied enough. So how is the central nervous system's neurons arranged? You can have a center, such as the visual cortex in the occipital lobe. You can have cell bodies in a gathering that has a specific function. Neural cortex is the gray matter covering brain portions, and all of the tracks, the bundles of axons that carry information to and from the central nervous system, from the spinal cord, and from all the sensory input of the body, and also send out information uh, to different parts of the body to control, particularly muscle contraction. In the peripheral nervous system, ganglia are groupings of cell bodies outside the central nervous system. A nerve is a bundle of axons. So we have primarily spinal nerves, which carry information to and from the spinal cord, and cranial nerves, which carry information to and from the brain. Okay, so let's look at this summary. So in the peripheral nervous system, if you have cell bodies, that's gray matter. White matter is the insulation of myelin that helps control conduction speed. Let me go back to the central nervous system. The neural cortex is the gray matter on the surface of the brain. Nuclei are collections of cell bodies that have specific functions. Centers are collections of cell bodies, so such as the visual cortex or the auditory cortex, and all of the cerebrum or cerebral hemispheres are the complex centers of the brain that receive information from all over the body and from the rest of the brain, and also control output after it's been processed, such as memory, executive function, intellectual activity, logic, and then so the higher functions of the brain are in the cerebral cortexes. Okay. White matter are called tracks. Several tracks together are a column, and that carries information to the brain and away from the brain. So ascending pathways are the red, and motor pathways descending carry information away from the brain, sensory to the brain. So the whole organization is to receive information from all around the body or different parts of the brain, and then integrate it so that we can have our glorious function of reading and playing music and riding a bike and doing math and so on. Let's go ahead and stop there. And we'll go back to about a 15-minute. Okay, stop recording for a moment. Stop recording.